take nice images here with a video camera. So, you have, yeah, here's one.
Good afternoon, everybody. And this is the third time that MISTRAS is represented in this competition, which I should call the American Idol of structural monitoring. So, let's see what we have today. In the past, we have presented to you two different acoustic emission wireless products. Now we'll bring to you another product that is wireless. In this case, it's an ultrasonic wireless node that has this configuration. This is actually the smallest UT multi-channel board that you will find in the market. And it's ideal for thickness gauging, time of flight diffraction measurements, touch point corrosion, and guided wave measurements. It was basically designed for the oil and gas industry and for chemical industry, but we think that this could be a good option for very practical use in aerospace. What I'm going to do is I'm going to start. This node actually runs based on our UT-Win software, which is our ultrasonic software. And I'm going to ask the person here with the camera to point at this little plate that we have here. And basically what we have is we have two sensors set up to measure the thickness in this step block, and a couple of sensors set up in a pitch catch mode to send a shear wave at 45 degrees. This could, by changing the angles and changing the frequencies, this could generate actually guided waves that we could propagate, of course, in metals several feet distance. In composites, it'll be a little shorter. That's what we think, although these are traditional metal industry type of measurements, they could be also used in aerospace. So what I'm going to do now is I'm going to start the node. And the control that I have here at the node is by individual channels. And right now, we're trying to communicate with the node. First time it takes a little bit of time. It has to wake up. Okay? Come on. Wake up. Could you clap at it, please? So it wakes up. Okay. See, this is what happens when you try and try. It works very nicely. And then all of a sudden, it doesn't. So, yeah, that's my luck. Okay. Let me. Yes, blame it on Windows. Okay, so we're going to start all over again. And here we go. Okay. We're going to ask it to wake up. Now it's going to wake up. All right. So what we have here is a signal from channel 1, which is this channel. And it's a sensor working the pulse cycle at 5 megahertz. And from those peaks that you see there, we can measure the time of flight between them and calculate the thickness. Now let me move on to channel 2. And we're going to wake up channel 2, and channel 2 is the 45 degree shear wave that is propagating on pitch catch mode between those two sensors. And let me move this guy over here. And I'm going to wake up channel 3. Here we go. And channel 3 is actually measuring in a thicker part of this plate at a lower frequency, 2.5 megahertz. So there you have it, 3 measurements. And we can actually program this node to take measurements every second, every week, every month, every year. Of course, that will depend on what are the needs of the customer. But we can actually program it to communicate to internet gateways, or to communicate through laptops, or to communicate directly to a SCADA systems in industrial installations. And of course, we could easily incorporate it into the monitoring, the data monitoring system on an airplane. So here it is. We hope that some of you take interest on this and help us to transfer it from its origin, which is, again, as I say, the oil industry, to the aerospace, because we think, this is something that, although it's simple in its concept, it actually provides some practical usage right away. And that's all I have for you today, and I thank you very much for your attention.